Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationct.com. In this session, we will solve a linear programming model using the graphical methods. Then we will solve the same model using the GAMS software. And finally, we will use the online solver provided by website www.optimizationct.com. At the end, we will compare the result of these three approaches. So let's get started. Here is the outline of our session, presenting the model, solving the model graphically, and finally solving the model using the GAMS software. Here is the linear programming model we will solve here. It has two variables, x1 and x2, and three functional constraints. We are going to maximize for x1 plus 2x2 subject to 5x1 plus 2x2 is less than 20, 2x1 plus 3x2 is greater than 12, and 4x1 minus x2 is equal to 0. We have a non-negativity constraint for x1 and x2. Now let's solve the model using the graphical methods. To begin, we draw the feasible region. The first constraint is plotted with using 2 points. 4, 0, and 0, 10. Okay, we plot here 4, 0. And 0, 10. This is first constraint. Since the origin, it means 0 and 0, satisfy this constraint because 0 plus 0 is less than 20. The area below this line is a part of the feasible region. So this is the feasible region. Second constraint is plotted using point 6, 0, and 4, 0, 4. Okay, 6, 0, and 0, 4. This is the second constraint. Since the origin does not satisfy the constraint number 2, the feasible area, because 0 plus 0 is not greater than 12. So the feasible region is above this line. The third constraint is an equation. So it's plotted using 2 points, 1, 4, and 0, 0. Okay, we plot here 1, 4, 1, like here, 1, 4, and 0, 0. Here, 1, 4. Since it has an equality, using the feasible region, include this line. So considering, so this is the feasible region. This line is the feasible region for constraint number 3. So we have two variables, x2 and x1. Because we have the non-negativity constraint, the feasible region is the first quadrant here. Okay, so the feasible region, this line, we use the other color. Okay, this is the feasible region. Now, to find you can see that the feasible region is a line. Now, to find the optimal solution, we plot the objective function for two values, Z is equal to 4. We have 2 points, 1, 0, and 0, 2. And Z is equal to 8. We have 2, 0, and 0, 4. Okay. Other color. Okay. 1, 0, 0, 2. Okay. Z is equal to 4. The other line, the line between 2, 0 and 4, this line. Okay. The Z is equal to 8 here. By increasing the Z, you can see that the objective function move upward. So the objective function would be at this point. This is the objective function. So in here, x star is 1.538 and 6.154, and z star is equal to 80.462. So this is the objective function, an optimal solution using the graphical methods. Next, we solve the same model using the GAMS software. GAMS software is a commercial website for commercial software for solving the optimization model in the form of the linear programming, integer programming, mixed integer programming, nonlinear programming, and so forth. So this is the code for this model. We have two variables, I is equal to 1 and 2. We have x1 and x2. Because x1 and x2 is non-negative, we write here the positive variable. Objective function is free in sign, so we just write variable objfu, it's z. Okay, we have one objective function and 4 constraints in the section of the equation, and we defined objective function and constraint number 1, 2, 3 in this format. So in GAMS, less than is equal L, equal is E, equal E, equal, and greater than is equal G, equal. So Z is equal to 4x1 plus 2x2. Constraint number 1, 5x1 plus 2x2 is less than 20. 2x1 plus 3x2 is greater than 12, and 4x1 minus x2 is equal to 0. We use the solve command to find the optimal solution using the NLP solver in the maximization form of Z. To display the result, we use this command, display x.l, or level of the optimal solution. So let's solve the solution. This is the code I prepared before, and this is the GAMS software. We open a new project, copy and paste, and just press the red arrow Okay, I can see that we find the optimal solution. The optimal solution, x1 is 1.538 and x2 is 6.1454, and the objective function is equal to 80. In this example, we explore how different types of constraints affect the feasible region. Sometimes the feasible region can be just a single line, like this example. But can a feasible region take other shape beyond the line or surface? Please leave your answer in comment, and we will discuss this question in the next video. Thank you so much for watching us. If you have any question or need help solving a model, feel free to contact us by email or filling the contact form from our website www.optimizationct.com. Do not forget to subscribe our YouTube channels to stay updated with our video. Thank you so much and goodbye.